Let's go. Okay, in this class we will see, last class we will see what is meant by sampling rate conversion and what are the types of sampling rate conversion. In this class we will see decimation, how to implement the decimation practically and how to implement the interpolation practically. First of all, decimation, you know that decimation, it is the process of reducing the sampling rate by an integer factor of d units. Generally, for the implementation of decimation, we have to use this black diagram. In this black diagram, where small down arrow and capital D represent, it will reduce the sampling rate by d number of units, and this AAF is called as anti-aliasing filter. First, that means the given signal first given to anti-aliasing filter to remove the that means aliasing effect. If there is any aliasing effect, it will remove the aliasing effect. Then it should be given to the decimator, which will reduce the sampling rate of the given signal by d number of units. Then the output of the given equation will be given as y of n is equal to x of nd. This is the general black diagram of the decimation, where we added anti-aliasing filter to remove the aliasing effect. But you know that any filter, you realize the number of realization for FIR system and IIR systems in the third unit. I think that is a FIR system, then its that means direct form realization for the given anti-aliasing filter is this one, where B0, B1, B2, B3, B4 and B are multipliers, Z inverse are called delay elements, and we have some summers. This entire structure is drawn by using unit number 3, direct form realization. So this entire black diagram is called direct form realization of decimation, where the entire filter have a separate structure. The output of the filter we should be given to a decimator, which will decimate the given signal by number of units d. But it is very complex. Why? Because we require more number of multipliers, more number of delay elements and more number of adders, and also and the final output is given to the decimator means some of the signal may be reduced. In that reason, we use some entities called signal entities. That means if given x of n and y of n addition to the decimator, output is y of n is equal to a into x of nd plus b into y of nd. If same case, if the decimator is given here in x of n part like this, then output is also a into x of nd plus b into y of nd. That means the first diagram, whatever the output we have, second diagram is also having same output. This is called signal entity 1. By using this signal entity, we can redraw the equation like this. In the previous diagram, decimator is here, but here we apply decimator in each and every loop. Why? Because to reduce the errors what we have produced in the designing of filters. To reduce the designing of filters errors, we introduce the delay elements or the decimator diagrams within the filter structure only. Okay. Coming to the interpolator, in implementation of interpolator, it is very required. You know that interpolation is used to increase the sampling rate of the given filter. Generally here, after interpolation, we have to apply some filter that is called anti-imaging filter. That means after incrementing the sampling rate, maybe some images are produced. To reduce that images or to remove those images, we require a filter called anti-imaging filter. This is the black diagram of general black diagram of interpolation. Here, the same concept, we have go for direct form realization. The anti-imaging filter direct form relation is like this. You know, we have a delay elements, we have a multipliers, we have some adders, but it is a direct form realization. There is some problem. If the interpolation have some exact value, this filter realization are reduced some errors or introduced some errors into the system. So direct form realization for interpolation is not good. For that's why reason we have to go for efficient or transposed realization. That means same using the entity 2, it is signal entity 2. Here I have x of n, y of n given to interpolator. Output is y of n is equal to a into x of n by I plus b into y of n by I. If I apply same interpolator in between same loops, x of n one interpolator, y of n another interpolator, the output is y of n is equal to a into x of n by I plus y into y of n by I. That means addition of signals is given to interpolator. Whatever the output we have, individual loop we have same interpolator, we have same output. This is called signal entity 2. By using the signal entity 2, direct form realization is rearranged like this. We have realization of filters. Within these filters, each and every loop we have to apply interpolators. By applying this such type of interpolators into the filters, we reduce the errors what we have in filter realization. This is called efficient realization of interpolators, which are used to reduce the errors in the designing of FIR and IIR filters. But it also reduces the number of multipliers and delay elements we require in the given system realization, but it is also increased number of interpolators we require. In the previous diagram, general there is a filter realization and there is a one interpolator, but here for each and every loop we have a number of interpolators. That means it will reduce the number of multipliers, number of delay elements, number of memory elements, number of adders. But there is a disadvantage, that is it will also increase the number of decimators and interpolators we require to reduce or to increase the sampling rate of the given system. In such way, we should realize the implementation of decimation and interpolation. Here we have used here we have seen what is meant by decimation, its block diagram, what is its direct form realization, what is its efficient realization. Similarly, what is meant by interpolation and what is the block diagram of interpolation, what is the direct form realization of interpolation, what is the efficient realization of interpolation. Majorly we use efficient realizations, not direct form realizations. Why? Because it reduces the number of multipliers, adders, and it also increases the number of that means decimators and interpolators. But interpolators and decimators is just a program. If we take a for loop, it will increase the number of values without having any practical problems. So in this class we will see implementation of decimation and interpolation. Next class we will go for the next topic called polyphase decomposition. Thank you.